Okay folks, we're back at some more charger testing. Finally got the correct sense resistor installed on the heatsink now. Probably wouldn't be able to see it in there, but when I get everything powered down I'll show you. A little bit of a look on the display here, which is now bolted in instead of sellotaped in. Running 7 amps at about 180 volts into our trusty fan oven heating element. I've three more of these guys on order, so when they come in we'll be able to take the power up. Also, what turned up today is the Unitrend power meter that I purchased on eBay, and I'm going to do a little video on this thing when I have a chance, because I think it's a great piece of kit at a great price also. Anyway, so what I'm going to show you guys now, hopefully we can get the backlight to turn on this little beauty, and what you're seeing up the top is the actual phase angle, and that's 354 degrees, and the bottom is showing the actual power that's being pumped into the charger from the AC side. Now if I scroll through some of the menus, we get to see the kVA, and we get to see the kVARs up top, which is quite small, which I'm very pleased to see. And let's go one more. Now we'll see the actual power factor, which is just jumping around a bit, but it's in or about 0.99 power factor, which is incredible to see that, actually, because this particular charger doesn't have the PFC stage installed in it. What else can we see on here? It's just a timer showing the actual power. Back to the mains display screen. I get the light on again. It shows us we're at 236 volts at 50 hertz, and we can go on again, and now we're back to the current. Now that current isn't true current, because it's not drawing 20 amps from the mains here. Because how can I tell that? Well, because we're on a 13 amp plug that has a 13 amp fuse in it, so if I was drawing 20 amps, A, the fuse would pop, and B, that little bit of flex that I have here is absolutely substandard for what I'm doing, but it's stone cold. And so that's also, and we're back to our power and phase angle display once again. So it'll be interesting to see if that changes any when I'm charging a battery. So what else have we got? Okay, so I've got the diff probe back on the IGBT again, and I hope this comes out okay, but we're on a slightly different scope this time. This is a little handheld Agilent storage scope, and this is the signal that I couldn't quite see with my analog scope. So thanks to some guys on the forums that pointed me in this direction, so we're able to see the that's across the switching IGBT. And I'm not sure what this is, this kind of jumpy bit here. I'm not sure what's causing that, but there's no nastiness so far. Now we're on a low power setting, so when we start pumping up the power here, the things will get interesting. So that's where we are so far. I'm going to just go ahead and see if I can turn up the power a small bit further, and we'll come back and see what happens. Okay, we're back again. Cranked up the power a bit. 9 amps, 212 volts, and input power 2.14 kilowatts at 355 degrees phase angle. I think our element is going to start glowing happily, and heatsink temp is 17 degrees C. So this is where it popped before on me, because the sense resistor overheated. So what I've got is my little cheap handheld temp gun here. I don't know if I'll be able to see this too well. Just got it pointed at the core here, the radiator. We're at about 13 degrees C on that. I'll try and just point it in here a little bit. Now we've gone to 12 kilohertz, which always scares me when it changes. Whoa, that's glowing happily. It always scares me when it does that little zip like that, so I don't know. I guess I'm paranoid. Anyway, just in on the bridge there. Don't know if you can see that, but it's at about, I don't know, 20 degrees C, 22 degrees C. Oh, 24, okay, wow. Going in onto the IGBT driver there now. Let's see if I can change this camera to macro mode and see if you can actually see some of this crap. Let's get it in there on the IGBT driver a little bit. There we go. It's just on the driver, which is warm. The IGBT itself, that's the casing of it. And then the bus bars there are cool. The big NKP capacitor. And my trusty scope is going crazy again. I'm gonna have to try and get a scope that, I don't know, just is physically able to deal with this, I think, because I don't think this thing can, but it's better than the analog scope. Just try and zoom in on it a little bit there. Try and do a run stop. There we go. That's it, stopped. Doesn't look too bad, I suppose. You can actually see the Miller plateaus on it there. Interesting. Okay, and run stop again. And we're off on another dancing scenario. And this is really starting to glow now. And some serious glowing action going on. Our power is, let's try and go through this power here. Looks like I'm going to be out of camera fairly soon, so I'll come back in a bit. Okay folks, just had to clear off the old memory card on there. We're back. It's been 20 minutes on power. Still holding 9 amps, 213 volts. We're still glowing away, and still on about 2 kilowatts of power. Various settings on here. Power factor is pretty good, but I don't know whether that's because that I'm on a heating element instead of a battery, but we'll find that out fairly soon. I managed to get the scope to calm down a bit. So this is our collector emitter of the IGBT. So so I don't know what it should appear to be, but it doesn't look too bad to me. There's our element. 3 more of these guys and we can start drawing some serious amps. Heatsink temperature on the display here is 19 degrees. Again, the temperature gun is just across it. The hottest point seems to be the IGBT driver itself. It seems to be about 30 degrees centigrade. Everything else is staying happy. So I guess that's about it at the minute. Try and get some video of a battery charge fairly soon, and get some. I have more of these elements ordered, so it's just a question of them turning up, and we can start doing some more power draws. Okay, I'm just gonna keep this on here for, I don't know, perhaps an hour, and that's about it. Okay folks, have a good one.